In this video, we're going to be talking about state changes. This is the second video in my TEAS Chemistry Essentials series. TEAS Chemistry Essentials has 8 video lessons covering the most important fundamental chemistry topics on the TEAS, and it's totally free. You can find all these lessons at teasinOneday.com, and you can also go there to download study resources like these worksheets and study guides that go along with each lesson. TEAS Chemistry Essentials is part of my full course on all of the chemistry that you should know for the TEAS exam. You can start with TEAS Chemistry Essentials and then move on to the full course when you're ready. And in every video in this series, I try to do 4 things. I try to guide, teach, practice, and reinforce the most important chemistry concepts for the TEAS. I want to show you exactly what you need to know, so it's crystal clear, even if you've never taken a chemistry class or even if it's been decades since you last took one. So let's get started here with state changes, video number 2. Remember to download the study guide and the worksheets that go along with this lesson at teasinOneday.com. Okay, previously in the first video, we learned that almost all of the matter or stuff around us can be sorted into one of 3 states of matter: solid, liquid, and gas. Here's what we're going to talk about in this lesson. The state of matter for a particular substance can change if the temperature changes. For example, here is some water. At room temperature, water is a liquid. But if we lower the temperature, when the water gets cold enough, it freezes to form solid ice. And if we have liquid water and we raise the temperature, water becomes hot enough to boil. It becomes steam, which is a gas. It probably won't surprise you to learn that these changes are called state changes. A change in the state of matter is called a state change. When water freezes, it goes from liquid to solid. State change. When water boils, it goes from liquid to gas. State change. Now, you probably already know these concepts. Our main focus in this lesson is going to be looking at all the types of state changes, and most importantly, taking a look at why state changes occur. State changes are explained by a set of rules called the kinetic molecular theory. The TEAS loves this. The most important thing here is that all matter is made of tiny particles. Let's think about the particles in water. We could show a bunch of them like this. Now, these particles aren't just sitting still. As we talked about in the previous lesson, you want to remember that these particles are in constant motion. They have kinetic energy, which we'll abbreviate as Ke. The particles are always moving. They might be vibrating in place. They might be moving from place to place, moving around. That's kinetic energy, the energy of motion. Here's the third important rule. We haven't talked about this yet. The higher the temperature, the faster the particles move. Hotter, faster. The higher the temperature, the higher the kinetic energy of the particles. That's the basic cause and effect here. Higher temperature, faster motion of particles. Very important. Got it? Let's use the kinetic molecular theory to see what happens when water freezes into ice. If we could zoom in on a glass of water, we'd see the particles of water. We'd see that they're moving around each other. They're kind of wiggling in place, kind of swimming around and past each other. They have kinetic energy. But there's another force at play besides the kinetic energy. See, all particles are attracted to each other. They want to stick together. they all experience what we call intermolecular forces of attraction, or IMF for short. IMFs are trying to pull the particles closer together. It's kind of like the particles are all tiny magnets. They're attracted to each other. Now, these two forces are in direct competition. Kinetic energy wants to move the particles around and move them apart, but the attractive forces want to pull them closer together and keep them together. So if you've got these two forces, who wins? Well, that depends on the temperature and the state of matter. In a liquid, like water here, the two forces are balanced. The particles are moving around, but they also stick pretty close together. But what happens if we lower the temperature? If we lower the temperature of water, the particles slow down. Remember, hotter faster, so colder slower. Their kinetic energy goes down, and they don't move as much. Lower temperature, slower movement. And eventually, as the particles slow down, the attractive forces kick in, and the particles start to stick together really closely. Remember, the particles are like tiny magnets? Well, the particles here that we're moving around, once they slow down enough, click, they stick together and they stick into place. The liquid turns into a solid, and you have a state change. Liquid to solid, freezing. Solids have a low kinetic energy. The particles aren't moving that much, but they have high intermolecular forces, high stickiness. So in a solid, the attractive forces win, and the particles in the solid stick together. We call this freezing. The phase change where a liquid turns into a solid, liquid into solid, is freezing. And so to freeze something, you have to lower its temperature, right? You lower the temperature so you decrease the kinetic energy of the particles. You get them moving slower and slower and slower, so the attractive forces, so the stickiness kicks in. Now, what happens if we move in reverse? What if we take this ice and we raise the temperature? Well, as things get hotter, the motion, the kinetic energy of the particles is going to increase. They're going to start to move faster. Eventually, when they reach a certain point, they break free of these really tight attractive forces. They start moving around more, swimming past each other, and the solid turns into a liquid. We call this phase change melting, solid to liquid. The attractive forces are still there. Remember, the particles in a liquid hold together, but a liquid is fluid. A liquid can flow into different containers because the particles can move around. They can move past each other. Let's look at what happens if we keep increasing the temperature. If we take the liquid and we get it even hotter. Higher temperature means more kinetic energy, which means the particles move faster and faster. Eventually, as they move faster and faster and faster, they're going to break completely free from the attractive forces, and they're going to spread far apart. We see that right here. These particles are really far apart, and they're moving really fast. When this happens, a liquid turns into a gas. The particles in a gas have a very high kinetic energy. They're moving around really fast, but very low attractive forces, very low intermolecular forces. They're really not attracted to each other at all. They're just flying individually all over the place, kind of doing their own thing. And this phase change, liquid to gas, is called boiling. Now, if we take a gas and we lower the temperature, the particles start to slow down. The kinetic energy lowers, and eventually these attractive forces kick in. The particles start pulling close to each other again, and the substance turns back from a gas into a liquid. We call this phase change condensation. Gas to liquid. The gas condenses to liquid. So that's how phase changes work. You have these two things that are balancing out. As you lower the temperature, the particles move more slowly and they stick together more. In a solid, the kinetic energy, the motion, is low, but the intermolecular forces, the stickiness, is high. As you raise the temperature, the particles move faster and they become more and more free. In a gas, the kinetic energy, the motion, is high, and the intermolecular forces, the stickiness, is low. So for the T's, you want to understand how these things relate. Temperature, kinetic energy, and intermolecular forces. Temperature, motion, and stickiness. You also want to make sure that you know the names of the phase changes and when they happen. Melting and boiling happen when you raise the temperature or when heat is absorbed. Condensation and freezing happen when the temperature is lowered and when heat is released. People are usually good with 3 of these phase changes, but it's usually condensation that they don't know. So remember to learn that one. Gas to liquid is condensation. Now, these phase changes happen at specific temperatures, and that's important. For example, at standard conditions, water has a melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. You can move in reverse too. Say you have steam at a high temperature. If you cool it down, when it reaches 100 degrees Celsius, it condenses into a liquid. So water's condensation point is also 100 degrees Celsius. And if we keep cooling it down, the liquid water freezes at 0 degrees Celsius. Notice that these temperatures do double duty. The melting point of water is 0 degrees Celsius, but that's also its freezing point. It just depends which direction you're going, whether you're adding heat or whether you're removing heat. And the boiling point of water is 100 degrees Celsius, but that's also the condensation point. Again, it just depends which direction you're going. Are you adding heat or are you removing heat? The TEAS expects you to have these numbers memorized. Water freezes or melts at 0 degrees Celsius, and it condenses or boils at 100 degrees Celsius. Now, you might be more familiar with Fahrenheit temperatures, 32 degrees for freezing and 212 degrees for boiling. But for science, we always use Celsius, so be sure to learn these numbers here. There are 2 other phase changes that we should talk about, and they're ones that you might not have heard about before. Sometimes a solid, as you can see here, transforms directly into a gas. It doesn't first melt into liquid. It's like it skips liquid and goes straight from solid to gas. We call this sublimation. Dry ice does this. Dry ice is frozen carbon dioxide. It looks like a white solid. We've got some right here. And it's super cold. When you take dry ice out of the freezer, though, it doesn't melt. It sublimates directly to carbon dioxide gas. In other words, you never get liquid carbon dioxide gas. And the opposite of sublimation can also happen. This is deposition, where a gas transforms directly into a solid without going through liquid. You might see this in a freezer where moist air turns to ice along the walls of the freezer. This picture here shows deposition. We have some purple iodine gas here, iodine vapor, coming out of the beaker, and it forms these solid purple iodine crystals, which are solid, on the bottom of the flask. The gas doesn't first turn into liquid. It goes right from gas to solid. That is deposition. Now, for whatever reason, I have no idea why, but the TEAS just loves sublimation and deposition. So many of the questions that they ask about state changes are about sublimation and deposition. So even though they're weird ones and we don't really experience them very frequently in daily life, make sure that you understand sublimation and deposition. So let's add these to our state change chart. We have sublimation up here and deposition down here. Again, notice the direction of heat flow. Red arrows mean that the temperature is going up and heat is being absorbed. Blue arrows mean the temperature is going down and heat is being released. Make sure you know all of these state changes by heart. The TEAS just loves to ask about them. Okay, let's wrap up with a bunch of TEAS practice problems. In which of the following phase changes does the kinetic energy of the particles overcome the intermolecular forces of attraction between particles? Let's look at these choices one by one. Choice A is deposition, where a gas turns into a solid. Now, for this to happen, the particles have to stick together, right? So they would lose kinetic energy. They'd get slower so that the attractive forces can stick the particles together. So this is wrong. We're going to cross it off. Choice B is freezing, where a liquid turns into a solid. This is similar to deposition. The particles would have to stick together more, so you'd have to lose kinetic energy. We'll cross this off. Choice C is boiling, when a liquid turns into a gas. Here you have to absorb heat and gain kinetic energy so the particles are moving faster and faster and they can break free of the attractive forces and turn into a gas. This is probably our correct answer, but let's just check D to be sure. Condensation is when a gas turns into a liquid. This also requires the particles to lose kinetic energy so they can stick together. So choice C is definitely correct. During which of the following state changes do the intermolecular forces of attraction become stronger? Select all that apply. Okay, well, when IMFs get stronger, the particles stick together more. Kinetic energy and motion would have to decrease for this to happen. So we'd be going in the direction of gas to liquid to solid. The IMFs get stronger and kinetic energy decreases. Let's look at the choices. Condensation is gas turning into liquid. So the particles would slow down and the intermolecular forces of attraction would get stronger. So we'll choose that. Melting. Solid turns into liquid, so the intermolecular forces of attraction would get weaker. I'm not going to choose that. C. In sublimation, a solid turns directly into a gas. The IMFs would have to get weaker here so the particles can come apart. They can move into the gas phase. So we'll cross this one off as well. Freezing. Liquid to solid. The intermolecular forces would have to get stronger to hold the particles more tightly together. So that's correct as well. And finally, boiling. Liquid to gas. The intermolecular forces of attraction get weaker because the particles have to pull away from each other and come apart. So we'll cross that one off and we're left with condensation and freezing. Here's another one. Naphthalene is a chemical used in mothballs. At room temperature, it turns directly from a solid to a gas. What is the name for this process? This is the type of question where you just kind of have to know some definitions. The state change where a solid turns into a gas is called sublimation. Choice C. Like we said, the TEAS loves questions on sublimation and deposition, so be prepared. Which of the following phase changes happen to H2O at 100 degrees Celsius under standard conditions? Select all that apply. If you saw H2O and didn't know what it was, you might have frozen up a little bit. Well, H2O is the chemical formula for water. We'll be talking about that more in future lessons, but for right now, just know it's another term for water. Well, most people will immediately choose boiling, and that's correct, but it's not the only answer. That's a mistake that almost everyone will make. Remember that water boils at 100 degrees Celsius, but it also condenses at 100 degrees Celsius. So condensation, choice D, is also a correct answer here. Ooh, this was a tricky question, but remember that two state changes happen at the same temperature, just in different directions. Let's try a harder question. Which of the following phase changes requires heat to be absorbed? Water freezing on a sidewalk, deposition of iodine vapor, the condensation of steam into water, or ice cubes melting. The question says that heat is being absorbed. So one of these changes is going to need heat to occur. That means an increase in temperature, which means an increase in kinetic energy. Choice A is water freezing on a sidewalk. But water only freezes when you lower the temperature. You need to decrease the kinetic energy of the particles, so heat must be released, not absorbed. So we can cross that one off. Choice B is the deposition of iodine vapor. Remember, deposition is when a gas becomes a solid without first turning into a liquid. Just like freezing. When a gas becomes a solid, you have a loss of kinetic energy. Heat is released, not absorbed. So we can get rid of B as well. Choice C is the condensation of steam into water. This is another phase change where you have a loss of kinetic energy. The particles move more slowly so they can stick together more. You would need to lower the temperature, get rid of heat, not absorb it, so we'll cross off C. And finally, we're left with D, ice cubes melting. Well, ice melts when you raise the temperature, right? The ice absorbs heat, the kinetic energy increases, and the particles move fast enough to overcome the tight attractive forces. The solid ice melts into liquid water. So D is the correct answer here. Well, that about wraps things up. By now, I hope you have a really good understanding of state changes or phase changes. And I hope you understand what happens during these state changes as the particles gain and lose kinetic energy as they stick together more or less. Now that you're done with this lesson, what's next? Well, make sure that you check out the study resources for this video at teasinOneday.com. And now, we're done with the 2 lessons from the Introduction to Matter topic. You're ready to move on to lesson 3, which is the first lesson in a new topic, Atomic Fundamentals. Lesson 3 is called Elements and the Periodic Table, and you can find all of these lessons at teasinOneday.com. I'll see you there.